All right, let's dive right in. Have you ever really thought about the amazing physics just hiding inside a simple bottle of water? Well, today, we are going to uncover the secrets of liquid pressure, and I promise you, it is way more fascinating than it sounds.
So let's start with this plastic bottle. We've poked some holes in it, but look closely, they're at different heights. Now, watch what happens when we fill it with water. You can see the streams are completely different, right? The one way out at the bottom shoots out like a rocket, but the one at the top, it barely dribbles out.
And that leads us to the big question. Why? Why does the water blast out of one hole and just trickle out of another? That is the mystery we're going to solve together today. Think of it as a little investigation into the secret rules that make liquids do what they do.
Okay, so to crack this case, we first have to figure out where this push, this pressure, is even coming from. What's the secret ingredient? What is this invisible force hiding in the water? Now, for our first piece of evidence, check out this experiment. It's just a simple glass tube with a rubber balloon stretched over the bottom. Before I show you the next part, take a guess. What do you think is going to happen when we start pouring water into this tube? And here we go. As the water fills the tube, look at that. The balloon at the bottom starts to bulge outwards. And this simple little effect shows us our first big idea. That bulge is being caused by the weight of all that water pushing down. It's just like stacking books on a table. The more books you add, the heavier the whole pile gets.
And you know what? This push has a scientific name. We call it pressure. In physics, it's just the amount of force acting over a specific area. So all that water weight getting focused on that little patch of balloon, that is pressure.
Okay, so now we know that pressure comes from the weight of the liquid. Let's see how that one clue helps us figure out our very first rule. And this one is all about how deep you go. Let's go back to our mystery bottle for a second. Take a look at the hole at the very bottom. It has the most water, the tallest column of water, sitting right on top of it. And of course, the hole at the top has the least amount of water above it. And that right there leads us straight to our first rule. And it's actually super simple. The more water you have above you, the more weight is pushing down, which means you got it, more pressure. So pressure always increases the deeper you go. This is a huge deal for deep-sea divers for sure. All right, we've got our first rule down. But that's not the whole story. The next piece of our puzzle is figuring out which way this pressure is pushing. Is it only going downwards? Let's find out. To answer that, let's look at a different experiment. This time, we have a bottle with holes poked at the exact same height, but just on different sides of the bottle. And what's the result? Well, look at that. The water sprays out with the exact same force from every single hole. And this shows us our second really important rule. At any single depth, pressure isn't just pushing down. It's actually pushing out equally in all directions, up, down, and especially sideways. That's exactly why those streams of water were all identical. Okay, we've got our two rules. 1, pressure gets stronger with depth, and 2, it pushes equally in all directions. You know what that means? It is time for the aha moment. Let's put these clues together and finally solve our original mystery. And here it is, the whole solution right here. In the bottle on the left, the bottom hole is the deepest, right? So it has the greatest amount of pressure pushing sideways, which is why its stream shoots out the farthest. And on the right, all the holes are at the same depth, so they all feel the exact same pressure and they shoot out equally. Mystery solved. Now, this isn't just some cool trick you can do with a plastic bottle. This principle is at work all around us in some really, really big ways. So let's take a look at how this knowledge of pressure is used in the real world. I mean, have you ever noticed that water towers or those huge water tanks you see on top of buildings are always placed way, way up high? It's not for the great view, I can tell you that. So using what we just learned, why do you think they do that? You guessed it, it's all about pressure. The sheer height of that tank creates a massive column of water. That height, that depth, generates a huge amount of pressure that's strong enough to push all that water through miles of city pipes and right out of the faucet in your home. It's really just a giant version of our bottle experiment. So after our little investigation, let's just boil it all down. What are the key things you really need to remember from all of this? Let's lay them out.
It really comes down to these 3 core ideas. First, liquid pressure is simply caused by the weight of the liquid itself. Second, the deeper you go, the stronger that pressure gets. And third, if you stay at one single depth, that pressure pushes out equally in every single direction. That's it.
So remember, these rules are everywhere. They explain why massive dams have to be built so much thicker at the bottom than at the top.
They explain why deep-sea divers need incredibly strong suits to survive. So now that you know the secrets of liquid pressure, I'll leave you with this question. Where else can you see these principles at play in the world around you? Keep your eyes open.